Alright, so now let's talk about half-life. And half-life is this idea of the concentration being halved repeatedly after a pretty much specific time. So if that didn't really make sense, it's like if you had 100 moles of a concentration and the question told you like the half-life is 10 seconds. This basically means every 10 seconds it's going to be halved. So it's going to go from 100 to 50 to 25 to 12.5 and so on every 10 seconds. And that's what half-life is. It's basically halving the concentration at this interval. So this concentration is going to be halved every 10 seconds. So after 20 seconds, this 100 is going to turn to 25. After 30 seconds, this 100 is going to turn to 12.5. So that's what half-life just is. But there are different half-life equations to use, and this is the one specific to first order. Now, you can actually I'm sure you can find a YouTube video going through how to find this sort of equation, how that actually looks like. And another way of writing this, I think it's to find your K, you could use ln of 2 over 1/2, and that's just to find your K, but this is just to find your half-life. And 0.693 is literally just ln of 2, but you can just memorize. It's just 3 numbers to memorize, so pretty easy to memorize. And this is to find your half-life, but specifically for first order. Now this is what second order looks like. This is the half-life equation for second order, and it's 1 over K and times the concentration at time equals 0. And that is your half-life for second order. But most of the time you're going to have questions about half-life that'll be about first order. So, and a lot of questions I've seen are mostly about first order. It's good to know the second order half-life equation, but this is the one you really want to get nailed down. The 0.693 over K is your half-life for first order. Alright, so let's look at our first question for looking at half-life. So it says the reaction is first order, and this is 2 hydrogen peroxide goes to 2 water plus oxygen, and it says a solution originally at 0.8 concentration of hydrogen peroxide is found to be 0.095 after 45 minutes, and what is the half-life? So if we remember our half-life equation, that was T 1/2 equals 0.693 over K. But look, in this question, we're not given our rate constant. We're not given K, but we are given a concentration, this initial concentration. So this should be H2O2 sub 0, and this would be the concentration at 45 minutes. So we can remember our equation. This was ln of H2O2, and this would be minus our ln of H2O2 at time 0, and that equals negative KT. So all we have to do is plug in our numbers. So ln of 0.095 minus ln of 0.8, that should equal negative 45K. So let's do this math. ln 0.095 is going to be negative 2.354. That's minus, and ln 0.8 is going to be negative 0.223. I'm just rounding for these, not writing all the numbers. So this is negative 2.354 plus 0.223, so that's plus, and we still have our negative 45K, so this should equal negative 2.131 equals negative 45K. So all we have to do is divide that negative 2 over negative 45. So when we do that, our K equals 0.0473, and all we have to do is plug in our K back to our equation, that half-life equation, and once we do that, it would be 0.693 over 0.0473, and let's see what that would be divided by that, and that should get us 14.6 minutes. So our half-life is 14.6 minutes. And since we weren't given K, we weren't given our rate constant, we just have to refer back to our integrated rate laws. And this was our formula, so I just have to put a T right there. But this is our concentration at a specific time minus concentration. The initial concentration equals negative KT. And as you can see from this math, we just found our half-life. And all you have to do is memorize your equations and see how they plug in. Because it's just like a puzzle. Solving all these chemistry questions are like puzzles, and you just have to use some equations for other parts. And we're going to see when we talk about elementary reactions, that's where it gets to a real big puzzle piece. And also the Hess's, I call it Hess's law for rate constants, but we'll look at that as well. But these questions are kind of like solving puzzles. And once you look at it in that perspective, then you can use a bunch of these equations towards finding the half-life, even if you weren't given the K.